All right, in lesson 37, we're going to talk about what's called inequalities. And before we actually get into the main part of this lesson, let's take a look at some of the symbols and inequalities that you've had in the past. Now on this screen, the first one that I have, and I'll draw an arrow to it, is the less than symbol. The second one is the less than or equal to. Now an example, let's go back up to the top one. When we say less than, an example would be 2 is less than 4. That would be an example using the less than symbol. For the less than or equal to, I could have 2 is less than or equal to 2, because it's one of the two. Notice that 2 is not less than 2, but 2 is equal to 2. So when I say that 2 is less than or equal to 2, that's a true statement. Now I could also use it in this. 2 is less than or equal to 4. Now here 2 is not equal to 4, but it is less than 4. The third one is the greater than. And an example of that would be 4 is greater than 1. Now the last one that we have shown is greater than or equal to. So greater than or equal. And an example of that would be 3 is greater than or equal to 3, right? It's equal to 3. Another example, and we could list example after example, another example would be 7 is greater than or equal to 2. It's greater than 2. All right, on the next slide here, let's talk about how this relates to the topic then in lesson 37. Now, you'll definitely want this in your notes. This is something that you're going to have to refer back to over and over again. Now, in these lessons where we're actually going to do some graphing, the less than symbol, which is the top one, we're going to use what's called an open circle on it. And right now this isn't going to make a lot of sense, but it will make sense when we go through some examples. So when we use an open circle, when we graph, that means that the number that we put the open circle above is not included. So I'm going to write, erase that part, but I'm going to write not included. So an open circle means the number it is above is not included in the solution. Now, the less than or equal to, we use what's called a filled in circle, which means that the number that it's above is included. And the greater than, we use an open circle, and remember what the open circle means, not included. And the greater than or equal to, a filled in circle, meaning included. So as you look at what I've just presented to you for notes, how do you know if you use an open circle or a closed circle? Well, I bet some of you have already can tell. An open circle is used when you don't have the equal sign underneath this symbol, right? The closed circle is when you do have the equal sign underneath it. Now some of you will remember that pretty easy. Some of you may have to refer back to your notes, so make sure you have a good set of notes here. All right, let's take a look at example 1. It says graph x less than 5. Now, the reason that we're going to graph them is because it's much easier graphing them. If I asked you to list numbers less than 5, how long would it take you to list numbers less than 5? Well, hopefully your response is it'd take forever, because there's unlimited numbers less than 5. So if we were to list them, that's going to take a lot of paper. So we graph them. So what we do is you make a line, and you put the arrows in, because a line does keep on going in different directions. And I want to show numbers less than 5. Now numbers less than 5 would be like 4, it'd be like 3, it'd be 2, and so on. So I want to show more numbers to the left of 5 than to the right of 5. So I might put 5 here, and I'll put 6 over here, and then I'll put 4. And this isn't the only way you can make the graph, but it's one example. Now, Since less than doesn't have an equal under it, I'm going to use an open circle above 5. Remember, the open circle represents that it's not included in the solution. So I use the open circle because less than, there's not an equal sign underneath it. Now, I want to show numbers less than 5, so I'm going to shade everything to the left of 5. Now, what this is saying is that since it's an open circle above 5, 5 is not included. 5 is not a solution. And you can see that that's true, because is 5 less than 5? No, that's an untrue statement. But anything to the left of 5 is a solution. That might be 4.9. That might be 4.5. That might be 1. That might be a negative 1. So any number, including decimals and fraction, to the left of 5 is a solution to this. And again, I'm emphasizing decimals because decimals are included here. So if I put 4.9 in for x, is 4.9 less than 5? And that's a true statement. So now some of you might ask, could you have made your graph, and I'm just going to sketch this out real quick, could you have had a closed circle on 4 and everything shaded left? And the answer is no, because you're forgetting about the numbers like 4.1, 4.2, the 4.9 I used above. Let's take a look at another example. Graph numbers greater than 4. Now, in this one, I'm going to add an equal symbol underneath it. Okay, so let's graph numbers greater than or equal to 4. So I'm going to make my number line. And since we want numbers greater than or equal to 4, I want more numbers to the right of 4. So I might have 3 here, and then my 4, and then mostly have numbers that are greater than 4 to the right of it. Now, since I have an equal sign underneath the inequality, this is going to be a closed circle on 4, meaning 4 is part of the solution. Because is 4 greater than or equal to 4? Yes, it's equal to 4. And then since we want numbers greater, I'm going to shade everything to the right. So anything that's above, anything that's underneath the closed circle, and anything shaded to the right is going to make this inequality true. As an example, how about 6? 6 is in that shaded area. Is 6 greater than or equal to 4? Yeah, it's greater than 4. All right, let's take a look at example 3. Now, in these next two and last two examples, we're actually going backwards. We have the graph. Now we want to write the inequality. So let's take a look at the graph. Okay, I have an open circle above 1. Now, open circle means that it's not going to be an inequality that has an equal under it. So since numbers are shown bigger than 1 because of the shaded area, right? Numbers bigger than 1, it's going to be a greater than sign. And then you just pick a letter. I'll use X. So what this graph is showing is numbers greater than 1. And again, I do not have an equal sign underneath the greater because the circle is not filled in. If it were filled in, I'd have an equal underneath the greater than symbol. All right, last example. Let's write the inequality for this graph. Now, it's a closed circle, and things are shaded to the left. So it's a closed circle, meaning I have an equal symbol, and since things are shaded to the left, it means less than, with the equal symbol underneath it. So this is showing numbers, I'll use A this time, less than or equal to 2. So, as you can see, we've given some examples and discussed inequalities for lesson 37.